Okay, so we're going to look for this Taylor series here. So find the Taylor series at 0 for cosine of 2 sine z up to and including the 6th term, so z to the power of 6. So how are we going to go about that? Well, the traditional way of getting Taylor series is to keep differentiating this maybe up to 6 times and see what we get to. But to keep differentiate that 6 times is going to be complicated. So we can use something called the composition rules. So we're going to use the composition rules for Taylor series. I'll just put TS. Okay. Now we're valid to use this in composition series because this function here is analytic everywhere. So that's going to be fine for us to do. And what we do know, the basis that we know, is the cosine Taylor series and the sine Taylor series. So let's just write that up here. So cosine of z, so cosine we know is an even function. So that's going to give us all the even terms. So that's 1 minus z squared over 2 factorial plus z to the 4 over 4 factorial minus z to the 6 over 6 factorial, and so on. We're only interested up to the 6th term, so I'm only going up to the 6th term here. And then the summation series for that is n equals 0 to infinity. Now we see that it's an alternating series, so it's minus 1 to the n. And the factorial is even terms, so it's 2n factorial. And the term here for the z is basically z to the 2n. Okay, that's basically what we know about cosine. So now we'll have a look for sine. So sine we know is an odd function. So now that's going to include all the odd powers of z. So we've got z minus z cubed over 3 factorial plus z to the 5 over 5 factorial. Now you could include the 7 if you wish. I'll just write it in just for the sake of it. And that's how the Taylor series for sine of z would appear. Again, all the odd terms. So now going on to the summation series. So n is 0 to infinity. Again, it's alternating. So it's minus 1 to the n. Powers this time are all odd. So now we need 2n plus 1 factorial. And then the corresponding power for the z is 2n plus 1. Okay, so that's the basics for our series there that we know. So now we want cosine of 2 sine z. So what we could do is for 2 sine z, if we just put a 2 in front of that, and then a 2 here, we can also put a 2 there if we wished. We don't need the brackets, but I'll just put them in anyway, just to make it clear. That will be our series for 2 sine z. So again, multiplying everything by 2. Okay, so now to combine them, what we do is we take this cosine series, and wherever we see a z, because that's our input for the cosine series, we'll plug in this series here for the z. So hence we'll do 2 times that and then all squared. So it's going to be looking something like this. So cosine 2 sine z, just write that z a bit clearer, that equals, so we put the 1 in, so that takes care of it. That's simple, there's no z involved, so we just leave it as it is. So now we'll go for this term, so this term done. So now we're here, so z squared over 2 factorial, well the coefficient is 1 over 2 factorial, so we'll just put a half, that's minus 1 half. And then we want z squared, so we want this squared. So we see we've got a coefficient here of 2. So instead of this 1, I'm going to cross that out and put 2, but we need to square it, so that's squared. And now we just write this series in here. We don't need the 7th term because we're only going up to the 6th. So z minus z cubed, 3 factorial, I'm just going to plug straight in as 6, and z to the 5, we can plug that straight in for 5 factorial. 5 factorial is 120. Okay, this term will go on. I'm just going to close the brackets. Now for the fourth power. So now we're going to add 1 over 4 factorial is the coefficient. So that's 1 over 4 factorial is 24. And now we want this to the power of 4. So 2 to the power of 4. So as I did before, take that out, write 2 to the power of 4. And then just write this in here. Just one thing, I forgot to put the square term there because we're going to square that. Now we want to put this term in here to the power of 4. So again, as we did before, z minus z cubed to the 6. Now we're going to the power of 4, so we're not going to need this fifth term here. So I'm just going to leave it at that. And then to the power of 4. And now for the sixth term, 1 over 6 factorial, and it's a minus. So plug that straight in. 6 factorial is 720. We've got a 2 here, which is to the power of 6. So I'm just going to write 2 to the power of 6. And then if we're going up to the power of 6, we're not going to need this term here. So I'm just going to write the z. And that's all up to the power of 6. Okay, I'll just put the dots in there just so you can see that term will carry on. Okay, so now we're going to simplify this up, make it a little bit more readable. So we've got the 1 that stays. 2 squared divided by 2, well, that's 4 over 2, so that just leaves us with a 2. And now with this, basically all we're going to have to do is just FOIL it because it's squared. So that would just look something like this. So we'll have z minus z cubed over 6 plus z to the 5 over 120. And then we just write it again. And just like in the good old days with quadratics, when we did those, we just FOIL everything. So be careful, z to the 6. So anything that's going to yield a power above 6, we don't need. So z with z, z with the cubed, and with the 5. This one here can go with those two. So that will go twice. And the z to the 5, we don't need with the z to the 5. Okay, so z times z, that's just going to give us z squared. So let's just put all that in here when we FOIL this out. So z squared. Z times minus z cubed over 6. And of course there'll be this one with this one, so it's twice. So that's minus z cubed over 6 times minus z cubed over 6. So then that's going to give us, z times minus z cubed over 6. That's going to give us minus z to the 4 over 6. And we're going to need 2 of those because there'll be this one with this one and this one with this one. So now we can put a 2 in there. And now we need a z with the z to the 5. And again, there's going to be 2 of those. So this one with this one and this one with this one. So z to the 5 is going to be a plus. That's going to be z to the 6 altogether. Z times z to the 5. Then over 120 twice. So I'll just put a 2 in there for now and leave it over 120. And then not forgetting the z cubed twice. So minus z cubed times minus z cubed would be plus z to the 6. 6 times 6 is 36. Okay, so that takes care of the squared terms. Now let's move on to this bit. 2 to the power of 4 over 24. 2 to the power of 4 is 16. 16 over 24 is 2/3. So it's going to be plus 2/3. Now this one here looks like it could be very, very difficult to FOIL out, but we will see in a minute that getting up to the up to the 6th term, this is not going to be so bad. So I'm just going to write it out so as you can see. Okay, it's always good to write it out so you can see what's going on. Okay, so we need up to the 6th term. So first of all the z's can multiply. That's fine. Let's just write that in now. Get that one out of the way. Now what we'll do is we'll have 3 z's together. and a z cubed minus 6. So that will give us z cubed times minus z cubed over 6. That's going to give us minus z to the 6 over 6. But what we can see is that there will be 4 of these. So the combinations of that will give us 4. So we can just put in a 4 just there. And then after that, we're going to get powers which are further on than 6. So a z squared times 2z cubed is going to give us z to the 8. Well, we're not interested in that for this question here, so we'll leave that out. So that takes care of that. That was easier than the squared one. And now we'll look at this one. So 2 to the power of 6. 2 to the power of 6 is 64. Let's just write that up here. Over 720. So what will that equal? Simplify that up. It's the common denominator, that's going to be 16. So that'll give us a 4. 16s into 720 will go 45. So 4 over 45 z to the 6. That's pretty straightforward. Okay, right. Well, this is technically the answer, but it's a little bit messy at the moment. So let's just do some algebra on this and let's just clean it up. So let's distribute the 2 into all these terms here. So that's going to give us minus 2z squared. 2 times this, that's going to give us minus 4 times minus will give us plus. Plus 4 over 6, that's plus 2/3 z to the 4. So that's that one. This one here now, minus 2 times plus 2 is minus 4. Minus 4 over 120 is going to give us minus 1 over 30. And z to the 6. And then 2 times z to the 6 over 36 is going to be plus 1 over 18 z to the 6. Okay, let's clean this one up. This one looking a little bit more straightforward. 2/3 times z to the 4. That's just 2/3 z to the 4. And then 2/3 times minus 4. Well, times minus 4 over 6, sorry. So let's just, minus 2/3 times minus 2/3 basically, because that will give us 2/3. So that's going to give us minus 4 over 9. And that's going to be a z to the 6 term. Let's just move that 3 out of the way to avoid any confusion. Okay, so that's that, and then minus 4 over 45, z to the 6. Okay, so now what we're going to do now is just add up or subtract the like powers, and that will give us straight into the answer. So let's go straight down and write our answer down. Cosine of 2 sine of z equals, so the 1 is the only coefficient, so that stays there. Z squared, now that's the only z squared term, so that's minus 2z squared. Okay, z to the 4s. We've got a 2/3, and we've got a 2/3. Let's just put a line under them when they're done. So 2/3 plus 2/3 is 4/3. So that's plus 4 over 3 z to the 4. Okay, z to the 6 is going to be a little bit more tricky. We've got a few more terms. Got this one, this one, this one, and this one. Okay, let's just write down under here how we're going to add those up. So it's minus 1 over 30 plus 1 over 18 minus 4 over 9, and then the last one minus 4 over 45. Okay, now what's this going to equal? So we need a common denominator, so we'll have 180. So if these are all over 180, let's just write the 180 here. This will be 6 times, so that's minus 6. This will be 10 times, so that's plus 10. This will be 20 times, just check that, yeah, 20 times, minus 4 times 20 is minus 80. And this one, 4 times, minus 4 times 4, minus 16. So that's going to add up to 96, 102, 112 over 180. So what we're going to simplify that as, well, we can get 8s and 16s, 8s into it. Can we get 8 into that? No, we can't get 8 into that. We'll go 4. Let's try 4 for a start. So 4s into that is 28. 4s into that goes 45. Okay, so they're now co-prime, so 28 over 45. And that will also yield a negative. So that's a negative. So that's minus 28 over 45 z to the power of 4. That is our answer. Okay, so a lot of arithmetic working that out. Very complicated, but take your time and it's very doable. Okay, oh sorry, this is z to the 6. Z to the 6. Okay, so we can see that we've got an alternating term still. So cosine here is alternating. So same here, negative, positive, negative. If we add an 8, this will be a positive, somewhere z to the 8, and then so on. Okay, thank you.